All right, welcome AP Psychology students. This video is dealing with Module 29, which is Lesson 3. We're talking about, now that we've talked about classical conditioning, operant conditioning, we're now going to look at how things like biology and cognition, the way that we think, how those influence how effective conditioning can be. So we'll kind of get into those. So if you look at the screen here, we can see that genetics can play a role. So the big idea here is that what species we are, our biology can predispose us to be more likely to be conditioned one way or the other. Some animals can, and the basic premise is that some animals can be conditioned to do things that they are more likely to do anyway, versus things that they are not likely to do. So think about, a dog. If a dog is, pretty good at barking or, shaking, whatever, it's pretty easy to condition them to do that. It's going to be harder to do things like have them stand on their hind legs or do backflips or things like that. So we have biological predispositions for how for what we can be conditioned to do. And a lot of it has to do with what's adaptive for the species. Is this something that's going to help me? Because again, the whole idea with classical conditioning is let's predict the future so I can avoid danger. What's going to help me? What's going to help my species survive? When you get into cognition, our previous experiences, things that we've experienced before, things that we've thought before, could make us more or less likely to be able to be conditioned, either classically or operantly. And the predictability, meaning if, with Pavlov, if every single time he rings the bell, the dog gets the food, the dog's going to learn quick that association. But if you ring the bell and only sometimes give the dog the food, it's going to take longer for the dog to learn that association. So how predictable it is really matters as well. When you look at things like generalization and discrimination, those things require cognition. For the dog to hear a chime and say, well, that's kind of close to a bell, I'm going to go ahead and salivate, or to discriminate and say, well, no, that buzzer's not close enough to the bell, I'm not going to discriminate that, or I'm not going to, salivate. That takes cognition, that takes thought. So all these things are going to play a role in how effective conditioning can be. A couple of names to know. One, John Garcia. His big thing would just be that he studied taste aversions. There's a video in this lesson that goes into a little more depth. I'm going to let them do the heavy lifting. But basically he studied how some animals develop taste aversions very quickly. And again, it's a survival thing. So things that might be poisonous, they learn to avoid those very quickly. So that was his big thing that he studied with rats. We kind of talked about this a little bit earlier, but pure behaviorists, they are very much like everything is nurture. The world outside of us completely shapes who we are. And so that's what the early behaviorists are thinking. Later, scientists come along and say, no, cognition plays a role in learning. Think about things like discrimination. Think about generalization. It takes thought to make the decision of this is close enough to the condition so I'm going to have that reaction. But early behaviorists didn't think that. They really thought you could pair any two stimuli and develop a conditioned response. It didn't matter. Pavlov thought it could be a bell with the food, it could have been anything with the food, and the dog would have learned it. And so these later scientists say, no, there's some things that naturally kind of go together better than others. One example of this, it's called aversive conditioning. This is something that they do with alcoholics. They'll have the alcoholic come into the doctor's office, the doctor will spike their drink with something that tastes horrible, and that the patient will drink it and they'll be like, oh, that's gross, and then they'll develop a taste aversion to alcohol and not want to drink it. So the question becomes, why doesn't that work all the time? Didn't we just cure alcoholism? Obviously we haven't. It's still out there. So what happens is the alcoholic learns the difference between, if I go to the doctor's office and have a drink, I'm going to get sick. But if I go to the local, come and go and grab a dirty 30 of Miller High Life, I'm not going to get sick. So that they've discriminated. And to do that requires cognition. So again, conditioning is not, we're not just robots. There's thought going on that plays a role in that conditioning process. So this slide here, again, just kind of sums up what we just said. So I'm not going to sit there and read it to you, but maybe pause and take a quick look at it. It's a nice summary of what we've talked about in the last minute. Again, just kind of to kind of put a cap on this with cognition and learning, Robert Rescorla, again, there's a video on him that goes into a little more depth, but his big thing was the predictability of an event determines how quickly, how effectively the conditioning occurs. So meaning for Pavlov, if you ring the bell and give them food every time, the dog's going to learn it quickly. But if you ring the bell and only give them food some of the time, they're not going to learn very quickly. So the predictability of the event is super important. That's going to develop what they call an expectancy. So how strong is the expectancy of, hey, whenever I hear that bell, I'm going to salivate, or whatever two stimuli you're connecting to one another. Couple other terms here. We're still kind of talking about cognition. This idea of latent learning. I find that this is pretty easy to understand if you just remember that the word latent means hidden. So this is hidden learning. It's learning that's taking place even when it's not apparent to others. So a little bit of background here. Edward Tolman does research on these mice, and he gives them, there's three groups. One group gets rewarded continuously as they learn a maze. Another group never gets rewarded at all. And then a third group doesn't get rewarded at first, but about halfway through the experiment, they start giving them rewards like pieces of cheese and stuff like that as they do the maze. And what they find is that the first group that gets rewards all the time, they do really well in the maze. The second group that never gets rewards, they do much worse. But this third group that doesn't get rewards at first, but then later does get them, surprisingly did, I think, just as well as the first group at learning the maze. And so the reason that that's important is it shows that you do not have to have a reward to learn. Again, early behaviorists are like, we're basically robots that are just being shaped by our environment, rewards, punishments, rewards, punishments. So this research shows that, again, you can learn without being given rewards or reinforcements all the time. And that oftentimes some learning is not apparent to other people. I mean, as a teacher, I see this where you have a student who, they're not really doing much in class. Do they know the material? I'm not really sure. And then, you give them an assessment, and then boom, 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 they knock it out. Here you go. And like, okay, you knew it. But it wasn't apparent until a reward or reinforcement was offered. So kind of a related term here with latent learning. As the rats learned the maze, this idea of a cognitive map. And, humans have this as well. All this is a mental representation of the layout of your environment. So think about, if you can imagine in your head, how do I get from my house to school? Or even, how do I get from my room to the kitchen or to the basement or whatever? So it's your ability to visualize your physical environment. So it's got to be a physical environment that you're imagining. How do I get from point A to point B? So, I mean, it could be even in your car. Okay, like where do I have to, reach to turn this knob or whatever, but being able to imagine a physical environment. So learning has taken place, and you may have gotten rewarded at some point, but the idea is that you were able to learn that even without an immediate reward. At some point, you were able to internalize that map. I think that's a good place to stop. I got a few other things to finish up in this section, but this is kind of a nice stopping point. So I got one other video in this section, so check that out, and we'll see you soon. Thanks, guys.